Okay, so when we know that a function is even or odd, okay, can't be even and odd because then it won't be represented as a function. Okay, so when we know that we have one of those, we can use symmetry work in calculating. Okay, so if I had the area of a to negative a of f of x, so some function of x that we know is even or odd, and way back in functions and graphs we looked at how a function is even and how a function is odd. Odd, f of x, except for you two, what's the rest of it?
Why are you so bad?
Hang on. Let's do even first. So f of x even is f of negative x. If you got that, it is even. And odd is f of negative x is negative f of x. Alright, and we did that way back in functions and graphs. Okay, so if you recognise that it's an even or odd function, okay, we can manipulate this to say like the integral from a to 0 of f of x dx, because all you're doing is doubling your symmetry area. Okay, so instead of breaking up into two parts, if it's odd, because one part would be above, one part would be below, okay, you can use this work to recognise when it is, if f of x is even or odd from that condition. Alright, so we've done that. You need to be able to do that. Otherwise, you're going to have to break it up and find your separate areas and add them together. Alright, let's have a look at a couple of examples. Find the area enclosed by the curve y equals x squared, the x-axis, and the line x equals plus or minus 2, plus n minus 2. Okay, so first things first, we are doing a sketch. Okay, so we should know that is a parabola bounded by 2 and negative 2. Okay, so f of x is x squared, f of negative x is negative x all squared, which is x squared, which equals f of x. Alright, so therefore your parabola, your quadratic here, just x squared, is an even function. Okay, because it has symmetry about the y-axis. Okay, that means when you have equally bounding points from the origin, these two areas are equal. Okay, and we set up the integration as follows. So area is going to be 2 times the integral from 2 to 0. So it's not 2 to negative 2 because you are doubling the area. You are finding one part of it and then you double it because of symmetry. Alright? And I stay clear of negative numbers. Okay? Why put negative numbers in here? We have nice positive numbers to work with. Okay, now, if you are going to take this approach, okay, you need to say something along the lines of due to symmetry. Or you can say f of x is even, for this particular example, okay, make a quick statement. Okay, so it's going to be 2 outside of x cubed on 3. From 2 to 0. And I'll also show you another little trick. Okay, when I'm multiplying or dividing by a constant number, okay, I can move that constant number out the front. Okay, so it's going to be 2 over 3 times the integral of x cubed from 2 to 0. Okay, because what I'm doing is really factorising this out because there are two terms that will have a 3 on the bottom, and I'm factorising that out the start. Okay, so any constant number you multiply or divide by, we can factor out. So 2 over 3, that means the brackets will still need to be there, of 2 to the power of 3, take away, and again, you can just put in 0. We don't need to write 0 squared, 0 cubes, okay? We don't need to do that. Okay, so it'll be 2 over 3 times 8, whatever the bracket simplifies to be. Okay, so the exact area between 2 and negative 2 of x squared, between x squared and the x-axis, is exactly 16 over 3 units squared. B. Okay, so we've got y equals x cubed, x-axis, and x is plus or minus 4. Okay, quick sketch. You're not getting marked on your sketch, okay, so be as rough as you want, as long as you've got a general representation of your curve. Okay, between 4 and negative 4. So first I'm going to observe that we have above and below. So I can't just do the integral from 4 to negative 4. If I do that, what will my answer be? 0. Okay, because of symmetry, you're going to have this area take away this area. Okay, so you need to do the sketch and separate your above the axis and below axis area. Okay, so x cubed, is that an odd or even function? Odd, we have symmetry for your x cubed, and the symmetry is above and below when you rotate it 180 degrees. So f of x is x cubed, f of negative x is negative x cubed, so negative x cubed. Now it's not equal to f of x, therefore it is not even. Okay, negative f of x is negative x cubed. Okay, and f of negative x matches that. Alright, so when those two match, we have an odd. Alright, and that's how you determine whether functions are odd, even, or neither. Because it's an odd function, the area is going to be double the integral from 4 to 0, where the symmetry meets, of x cubed dx. Okay, you can set it up differently. Okay, I'm not saying you have to do this, but if you use it, this will save you quite a bit of time, particularly in doing your homework task and assessment conditions. So equal 2. Okay, so we all should be good at integrating now. And now that I'm dividing by a constant number 4, okay, I can factorise that 4 out. So 2 over 4 becomes 1 over 2 of x to the power of 4 from 4 to 0. So you don't have to do this, okay? Again, I'm just showing you what you can do to make life a bit easier for yourself in the long run. So half 4 to the power of 4, take away, of course, 0 again. Won't always be like this, okay? Sometimes you have 4 to 1, you can't just write 0. Alright, 4 to the power of 4 is the same as 2 to the power of 8, which is 256. So 2 to the power of 8 divided by 2, 2 to the power of 7, which should be 128. And again, so under cubic, between 4 and -4, the exact area is a whole number. It's an integer. Wow, pretty cool. Alright. Any questions on the approach? Can everyone understand the benefit of taking this approach? Okay, so that's why I'm showing you.
How do you crank a butt? I don't think I've ever had a butt car.
Really?
Yeah,
No, I just never saw that.
like upper thigh. Or butt.
Okay, in your homework task, you can write now exercise 3.6. The theory was covered today on the 27th of the 10th.
What number?
3.6. Exercise 3.6, which covers the area and also looks at even odd function. 3.6. Exercise 3.6, the theory was covered in class on the 27th of the 10th.
Sweet.
Okay, so we need to keep on top of your work. So by our third lesson, this should be done. We have 2 more lessons this week. That means Monday next week, this should be aimed to get completed, as well as all your previous tasks should be done as well. That's the sort of mindset you need to have.
When did we do the extension stuff? Are we done for? Yeah, we're done.
No, I'm going to do that today. I'll send a photo on Thingo, just of what I've scribbled out. I haven't done a formal copy of it yet. I hope we get it done today. But, so why is... so going back the other way, not integrating, we're going to differentiate. Okay, so dy over dx is going to be 3x squared plus 4x. Okay, which is not linear, because this is the equation to give you the gradient of the tangent. Okay, and that's what dy dx is, isn't it? It's the gradient. Okay, so
that never occurred to me. That dy over dx is actually like y is over 1. That makes sense now.
Alright, so at x equals, let's say 1, alright, we can then determine the slope of the tangent. Alright, dy over dx is 3 plus 1, which is 7. Okay, so you're going back the other way. So you know the line makes an angle of 135 degrees to the positive x-axis. So therefore the gradient is -1. So when you have your d squared y over dx squared equals whatever it was, okay, and then you integrate both sides, you'll have a dy dx is whatever that is, plus your first quantum integration. Okay, you were told the x value. So x equals whatever it was, let's call it a, whatever it was. Okay, but I know that dy is -1. So that's why I replace this bit. So -1 equals whatever plus c. Okay, so then dy over dx equals all that and whatever the value you find for the constant. Okay, so you have to do it twice because then it gave you a point. But when you integrate this again, you're going to have a y equals plus the second constant of integration, and then that's when you substitute that point in. Okay, but you have to do this first, and that's what the information gave you. dy dx gives you the gradient of the tangent. Okay, makes sense now?